Hello and welcome to a fresh ramble. We are drawing nearer and nearer to the end of paper 2, IEB November 2022. This is our second last question from that paper. Question 13. In the diagram, the circumscribed circle for triangle BCF is given. Okay, so we have triangle BCF and a circle that encloses it, right? And circumscribed specifically means that B, F, and C lie on the circumference of the circle. A, B, and AC are tangents to the circle at B and C respectively. I'm immediately thinking AB and AC are equal because, tangents intersecting at one point. Tangents also make me think tan rad, but we don't have a center of a circle yet, so maybe not. Then I'm thinking tan chord as well, so with this tangent there's that angle, for example, and this chord, so we have that angle being equal to this one, this angle and this chord. Right, and then with this tangent we have this angle, and this chord we have that angle and that chord. So lots of opportunities for tan chord, which is very exciting. Right, FE, FG, FE, FG, and FD are perpendiculars from F to AB, F to BC, and F to AC. Okay, cool. Right, then we're asked to prove that triangle FEB is similar to triangle FGC. So I'm just gonna highlight them for myself real quick. No? Or maybe color them. Wouldn't that be fun? And FGC. Oh, okay, that's good enough. Right, so I mean, okay, we already know that's a 90. That's a 90. Angles on a straight line, or just the fact that, perpendicular. So this is a 90. Oh, yummer. Okay, and then tan chord for this angle, because we have tangent chord subtending this angle over here. So those are equal, and then this will be third angle. Okay, easy enough. So angle E in triangles FEB and FGC, okay, we have angle G1 is equal to 90 degrees because we were told that FG is perpendicular to BC, right? And therefore angle E2 is equal to angle G1. Okay, right. Then secondly, it's crazy that I'm even writing this, honestly. I don't need to rub all of that out, honestly. Angle E2 is equal to angle G1. It's given. I don't even have to explain how and where it was given. It's given. Right, so those are both 90s. And then angle B1 is equal to angle C2 because of the tangent AB and the chord FB. Right. and then angle, oh, why didn't they number the F angles for us? EFB is equal to GFC, because third angle in triangle, right? Angle sum vibes. So therefore, triangle EBF is similar to triangle GCF. Right, and the reason is angle, angle, angle. Cool, and that's that on that. Right, so then the next thing we're asked to do is to prove that FG squared is equal to FE times FD. Okay, first we readjust. Oh, don't mind all the kushu. Okay, right. FG times FG is equal to FE times FD. We are also armed with the knowledge that these two triangles are similar. Rodikana Isa Narufuni Dadaba Shurudu. Okay, so FG shows up in this triangle. FE shows up in this one. And I mean, if we just rearrange this, so this is FG times FG is equal to FE, space constraints, times FD. So if I just rewrite these as ratios, I can see that from this relationship here, FG has a relationship with FE, right? So I'm going to divide by FG to get rid of one of these, and then divide by FE, and then do the same on this side. And I'm doing this just so I can get a hint of, you know, what to try to prove. So here I'm left with FG over FE. Here these cancel out, and I'm left with FD over FG. So this is just stating in another way what I need to prove. So let's see, FD and FG. Right. So I could be trying to prove, I mean, even just visually, these triangles look similar. So if I could find some ratio connecting FD and FG, maybe I'll also find something about, you know, something about the sides that show up in here that can then bridge me back to this somehow. So I'm just gonna do this a bit roughly. No, I'm not gonna do it roughly. So let's see, in triangles FTC, and okay, no, I do need to do this roughly because I just need to make sure that I'm not chasing my tail. So I'm looking at these two triangles. Let me color them again. Well, not again, you know, as in I'm coloring different ones, but I'm using coloring again, is what I mean. Okay, so we have a 90 in both of them. We have tan chord, right? Because tangent chord subtending that angle over there, and then third angle. Okay, so they are similar. So we have FDC and FBG. Okay, so angle D2 is equal to angle G2 given, and then angle C1 is equal to angle B2 because of the tangent AC and the chord FC. Okay, and then the last angle is angle DFC is equal to angle BFG, because third angle and triangle, right? And therefore triangle DCF is similar to triangle BFG, because angle, 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 right? So what does that give to us here? So we are looking for something that connects FD and FG. Okay, and indeed we see that FD and FG are not the related ones. Oh, I messed up my order. Oh my goodness. That's GBF. Okay. Right, angle D is equal to angle D. Yes, okay, that's right. So FD and FG are indeed the ones that are proportional to each other. Is there anything about FG and FE? No. What sides do these triangles share in common with these triangles? Well, FC and FB, and they are the related sides in this little situation here, FC and FB. So what does that tell us? That tells us FD to FG is the same as FC to FB, and that is going to bridge us back to here, where FC is also proportional to FB, and that's going to bring us back here. Hooray, 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 hooray. Let's write it all out. So in this situation here, we said that we are interested in getting this, the FD and the FG, okay, and then the FG and the FE we're going to get over here, FG and FE. Then we need to look at what's common between them to build a bridge, and we saw that FC and FB are common to both of them, FC and FB, FC and FB. So that's what I'm going to lift. Okay, so from both of them we're going to lift FC and FB. Okay, and from this one we said we want to lift the FD and the FG, and over here we're going to lift the FG and the F. What? I've lost my train of thought. So okay, these are common to both of them. From this one we want to lift these guys, FD and FG. From this one we want to lift these guys, the FG and the FE. Okay, that threw me off for 2 seconds, but we're back. Right, so here we go. And over here we know that, okay, I'm just gonna start with FC so that we have the same fraction here. FC over FB is the same as FG over FE. Right, and so therefore FG over FE is equal to FD over FG. Okay, then now we can do our cross multiplying magic. We end up with FG squared is equal to FE times FD. as required. Okay, so I'm definitely like happier with my developing strategy to questions like these, where you kind of use the statement, rearrange it, so it's often going to be presented as a product, rearrange it so that it's fractions, right? Because once we have the fractions, then we can kind of start to see which triangles do we need to work with. So over here, I also took a hint from the previous question, right, where we were asked to prove similarity between this triangle and this triangle, right? And we saw that there was a relationship between FG and FE, right? So I then choose my divisor smartly so that I end up with an FG over FE on the one side, and then see what I'm left with on the other side, and I'm left with an FD and an FG, FD and an FG. It's like, ooh, okay. Is there a system of similar triangles that I can use that connects these two sides? And at first it just felt like intuition that these two triangles are it, but then after just roughly looking at what are their angles like, it's like, oh snap, they are similar. And then from there we look back at our statement to say, okay, so what do we want from each, because we end up with two systems of similar triangles, these two and these two. So what do we want from each of those systems to arrive at this statement over here? And that's how we choose which ratios to be concerned with. And the most important thing being, well, we also need to identify a ratio that's going to be common to these two so that there's a bridge between them. Right. Definitely looking forward to attempting another question like this in future, now that I feel like I have a bit more of a calculated approach to them, as opposed to just kind of stabbing blindly in the dark and hoping somehow, somewhere, to bump into, the desired result. Thanks for tuning in, and yeah, I don't think I need to check anything with the memo. I'll just briefly look and see if something catches my eye. Nothing catches my eye, so I'm out of here.